Hello everyone, welcome once again. Continuing from the worksheet 1, algebraic expression, you can count as part second on the topic algebraic expression. So here on the screen, we are able to see the further questions where we see question number 6, which is asking us to evaluate. Now in this question or from this question, we can see the type wherein we find that how or we are coming across the situations where we are to add, subtract the algebraic expressions. So as a student, we are comfortable with adding, subtracting the numbers, but now as in the world of algebra, the variables are involved which are having uncertainties, plus we are not used to with them in our day-to-day life in that much way as we are with numbers. So adding them, subtracting them can create some complexities, but once we are trained enough, we practice enough questions, we get skilled to manage them as well. So if we see question number 6 part A, where we see the question goes in this manner: b square y minus 9b square y plus 2b square y minus 5b square y. So first thing which we should check is that whether the things which we have to add, subtract, they are like terms or not. Because that is why before this like term, unlike term has been introduced, because only the things which are same can be added or subtracted. So like terms can be added, and as we know that variable portion needs to be exactly same. Suppose it is xy, so all the other terms we check which is having xy as the variable portion, and they can be added and subtracted. So likewise, if we see in our question, we see b square y. So b square y, only b square y is having coefficient what? 1. Then we are having minus of 9b square y. Then we have plus of 2b square y. And the good part is that all the terms are what? Bring your attention to the variable portion: b square y, b square y, b square y, b square y. So all are what? Like terms. That is the good part in this question. Now we need to bring our focus attention on the coefficients. So first term is having coefficient 1, positive 1. Second term is having negative 9. Third one is having positive 2. And fourth one is having negative 5. Now from here, your concept of integers will help you. So in integers, in order to add, subtract the number, what we know that positive numbers can be added together and the negatives can be added among them, and then we can deal finally with them to reach to the final outcome. So if we check for the positive numbers, we are having 1 and we are having 2 as well. So 1 plus 2 will give you how much? 3. So you get 3b square y. Then for the negative numbers, if we see, So negative numbers we are having minus of 9, and we are also having minus of 5. So now we know that minus and minus is written together, not multiplying. Minus 9, minus 5. So if both the numbers are negative, we do the work of addition. We do the work of addition. So 9 plus 5 is going to give us 14. But minus minus, so final answer will also have the sign of minus. The sign is maintained, negative sign. Because these are two negative numbers. So they will add up to become negative number. So we will get what? We will get minus of 14 b square y. Now, in the last step, we see one number as positive 3 and the other number is negative 14. So again applying integers, 3 minus 14 or 14 minus 3. So 14 minus 3 will give you how much? 11. And as per the rule of integers, 11 will have the sign of the number which is bigger, at least magnitude wise. So it is minus 14, so the final outcome will be minus 11. So minus of 11 and the variable running is b square y. So this is the last step, and with this becomes our final answer. Thank you. So continuing to the next part B, which is going to be more exciting. So we see in part B, the question this time is 3x square minus, 3x square plus 5xy minus 4y square plus x square minus 8xy minus 5y square. So now we are able to see different types of variables in different terms. So we need to segregate and bring the like terms together. So if you want, you can write in this manner also, that if we make a column of x square and another column of xy, another column of y square, any other type of variable? No. So we have x square, 3x square, we will write it under this column. Then we have 5xy, positive 5xy, so we will write under this column. And then in y square we have minus of 4y square. These are the first three terms separated. Now the next three terms, x square will come under x square, minus 8xy will be placed in the column of xy, and minus 5y square will go in the category of y square. Now we can add them separately. So 3x square plus x square, and x square is like 1x square. So 3 plus 1, 4, followed by x square. Other situation is 5xy, and other one is minus of 8xy. So 5 minus 8 situation is there. So 8 minus 5 can be done, which will give us 3. And variable running is xy. But we can't skip the signature, the sign, sorry. So minus of 8 and plus of 5. So the bigger number is 8. magnitude wise. So the sign will be given minus to the final answer. Minus 8 plus 5 will give you minus 3. Then next is y square, where we see minus 4 and minus 5. So integer will say that both of them will be added because they are sharing same sign, same type of number. So 4 and 5 adding gives you 9, and minus, both numbers are of negative nature, so the final answer will be also negative nature. Now we can write them together. So we can say 4x square minus 3xy minus 9y square. Now they are unlike terms, so they cannot be treated among themselves. So this is the final thing which can be done over here. This is the answer. Clear, students? There can be your way of also solving the question. Just that it should be logical and easy to comprehend. So next, if we see, we are having question number 7, which is about addition of algebraic expressions. This in the first part says a minus 3b plus 3. The second expression is 2a plus 5 minus 3c. And the third one is 6c minus 15 plus 6b. So as we all know, the like terms can be added or subtracted. So let us start. As in we see a minus 3b plus 3 is the first expression. Now when we are writing the second expression, we can go by the column method. So 2a, all the like term can be written in a vertical column, one below the other, which will make the process easier, less confusing. And 2a is followed by 5. So 5 should go where? In the constant. So we are having 3 in the previous expression. We can write below that what? 5. And positive 5 because in the question it is having a plus sign before it. So it is positive by nature. Then we have finally minus 3c. Now do we find any c term, any term having variable c in previous expression? No. So there is no place over here. So all the extra, or you can say new one, which were not existing previously, we can write in the last. So minus 3c. And then if we see the third expression, it starts with 6c. So now we have another member of this category, this type, this term, 6c. So below the c. Then minus 15. So it's a constant. We are having a column of constant. Now we need to specify the sign of 6. So by default, numbers are considered to be positive. Then we have 6b, positive 6b. So we are having a column of b. So there goes 6b. Now it is time to add them. So a and 2a will give us 3a because a is having what number? 1. 1 plus 2 is 3. Then if we follow next, we are having minus 3b and plus 6b. Minus 3b and plus 6b. So minus 3 plus 6 integer wise will give you plus 3 followed by the variable b. Sorry. Then if we see the constant column numbers, so we have plus 3, plus 5 and minus 15. If we add plus 3 plus 5, it will give us 8 and minus of 15. So positive 8 and negative 15. So 15 minus 8 gives you 7. Sign will be minus of 7. Then again last minus 3c plus 6c. So again integer wise, minus 3 plus 6 will give you plus 3 and c. One more thing is there which I would like to share, that in your final answer the terms can get shuffled, like plus 3b can come in the last, or plus 3c can come in the place of 3b. So terms can change their place, and in both the situation, in every situation, if terms are shuffled, the answer is not changed, answer is same and correct as well. So that can be done, that is allowed. So that was question number 7. So next part, if you want you can go with part C, because there are powers and maybe you may find it complicated, just a hunch. So let's see part C, question number 7, part C. That is quite thick, let me adjust the thickness of the marker. Fine. So we are having x square, I should write in the white space. So we are having x square minus of x square y plus of 5xy square and plus of y cube. Right, that was your first algebraic expression. Now if we see the second expression, we are having x cube. So do we have any x cube previously? No. So we can write it separately, either in front or in the last. So minus of x cube we got. Then minus of 9x square. Do we have xy square? Yes. Third term. So we can write below it. So the term is minus of 9xy square. Then plus y cube. So we are having y cube previously as well. So below y cube we got another y cube. Now coming to the third and last expression, 3x square y. So do we have x square y? Yes. Yes. So we'll write below it 3x square y, and as no sign is there, will be considered as positive, plus 9 of xy square. So do we have xy square? Yes, we have, very next to it. So we will write there plus of 9 xy square. Right. So these are all the terms given in the different expressions to add. Then you can do like this, just to understand the empty spaces. So minus of x cube will get the same thing without any change. Then x square is having what sign? Positive sign. So we will write plus x square. Next term is minus x square y plus 3x square y. So minus 1 plus 3. Minus 1 plus 3 gives you positive 2 variable, no doubt, x square y. Then we have plus 5xy square, minus 9 and plus 9. Now minus 9 and plus 9, we can say that they are cancelling each other and we are left with plus 5. So we will write it down, plus 5xy square. Then y cube plus y cube. So 1 plus 1, 2. So we get finally 2y cube. So that is That is our final answer. Thank you, everyone.